Two, it's stupid but funny. I remember when I was in high school, I was like, man, algebra is so easy. If I could just get a job solving algebraic equations, like easy ones, and just that would be my life. Um, and here I am. All right, so anyway, so let's solve for h on this one. A couple things going on. Long story short, I think I want to multiply by 2. I think that'll be the easiest first step here. 2a is going to equal bh, and then I can divide by b. So this is going to equal h is going to equal 2a over b. I guess I should go into this. Obviously, h is being multiplied by b and dividing by 2, but multiplication and division happen at the same time. So it's really up to you if you wanted to divide b. As a matter of fact, I guess I don't want to make this video too long, but the idea is that multiplication and division happen together. So h is multiplying by b and dividing by 2. So what if I just decided instead I want to divide both sides by b first? I would have got a over b equals a half of h. I can have multiplied by 2, and you could see I still get 2a over b equals h. So as far as order of operations go, it was pretty difficult to screw that one up. Either way would have been fine in terms of order of operations. All right, so let's go with this one. We're solving for x, and I think what I'm going to do is just distribute and write over here. So I'm going to get 2x squared minus x is equal to 2x squared plus 5x minus 12. So you can see I distributed here. I'll tell you right now, at this point, everything you guys do is going to be set up to where the x squareds get rid of each other, although you will learn in integrated 2 and integrated 3 how to sort of solve those, but at this point they should just cancel out because we're not going to do that in integrated 1. I'll move this negative 5x over here, so I will get negative 6x equals negative 12. I'll divide by negative 6. So obviously x will equal 2. By the way, I want to say here, this is algebra, so there's so many different ways that you could solve these things that you may be doing it a different way, which doesn't matter. Just like I showed in the first one, as long as you're getting a correct answer, that's all that really matters. All right, so 3x plus 6y equals 24. I'll subtract 3x. I will get 6y equals negative 3x plus 24. Divide by 6. Obviously, I get negative 1/2 x plus 4 once I simplify that. So negative 1/2 x plus 4. Let's go to D. Same thing, I'm going to distribute as I go. So I'm going to get 2 minus 6x plus 3. Again, that negative gets distributed to both those terms. Is going to equal negative 6x plus 5. I'm trying to solve for x, so kind of a pain. This equals 5. I'll add 6x to both sides. We saw one of these at the end of 611 where it's just 5 equals 5. Well, 5 equals 5 is true. That means this is the same line twice, so we'll say it's all solutions. There's nothing that you can plug in here that will make that false. All right, let's go to E. On E, again, I'll distribute, so I'm going to get 10x plus 2z equals 30x plus 3y plus 10. I need to solve for x, so I don't know, I guess I'll subtract 30x over here, and I'll subtract 2z over here. That will leave me negative 20x equals 3y minus 2z plus 10. And at this point, I will divide by negative 20. So I'm going to get x equals negative 3y over 20 plus 1z over 10 minus 1/2. So a couple things going on here that I want to talk about. I was dealing with the positive and negative, right? A positive divided by a negative is a negative divided by a negative is a positive, and a positive divided by a negative is a negative. At the same time, I was simplifying. 3 and 20 don't go into each other, so But 2 goes into 2 and 20, so I can call that 1 and 10. And 10 goes into 10 and 20, so I can call that 1 and 2. So your solution here is going to look something like this. That's supposed to be 1z right there. It's probably better if I just actually put a z right there, I think. Ugh, I'll just rewrite that whole section. There we go. I don't know if I screwed something up. That's a crazy answer. I should probably go back through at the end and make sure I didn't screw that up. Actually, let me pause it right now and make sure I didn't screw that up. The book didn't actually go through the trouble of simplifying it, so it left it as like negative 3y plus 2z minus 10 all over 20 or whatever it was. It just didn't individually simplify those like I did. Well, either way, I guess I think you should simplify, honestly. All right, here we're going to distribute the 4x. So we get 4x squared plus 4x is equal to, and again, we'll do the area model here as we go. So 2x minus 3 and 2x plus 5, we get 4x squared, which we expected to see because those need to cancel each other out. Because like I mentioned earlier, we don't know how to solve those yet. So I'm going to get plus 4x minus 15. So this one's a little bit more interesting. It's very similar to D, except for when we're done with it, we get 0 equals negative 15, which is actually false, which means there's no solution. There's nothing in the world that you're going to be able to plug in here. So on D, there's nothing you can plug in to make it false. On F, there's nothing you can plug in to make it true. We'll be discussing that more as this chapter goes along with parallel lines and stuff. All right, here we're solving for x. So again, I will, you know what I'll do on this one? I kind of like to take the shortcut. I don't really like to distribute if I can avoid it, so I'll just divide both sides by 5 and get negative 3 plus x equals 7. I'll add 3, so x equals 10. That would have been a good one, actually, just to sort of look at like we did in chapter 1 or chapter 2, whichever chapter, and said, hey, look, 5 times 7 is 35. What makes this thing equal 7? And that would obviously be 10. Moving along, H, we're going to solve for M. This game is a little tricky because M's on bottom. So the first thing you need to do is multiply both sides by M. And what that accomplishes is it moves M to the top level. I hope you see what I'm saying. Here it was on the bottom, but here it's on the top. So now I can just go ahead and divide both sides by A. Again, there's other ways of looking at that, but I've found over the years that more people seem to understand that logic than the other ways of talking about it. So we'll just leave it with that. Let's go with I. Sorry, this looks like such a mess. So we're going to solve for B. AB minus 2 equals 3C. So I'll add 2 to both sides first. And then I'll divide by A. So B equals 3C plus 2 over A. And finally, last one, we'll go ahead and solve for W. So like I said, I'll distribute as I go. So I'm going to get 2V minus 6 is equal to 1. I have to distribute this negative, so that's negative W minus 4. So I'll subtract the 1 and add 4 to both sides. So minus 1 plus 4. It would have been way more sense to collect those terms, but I didn't. So anyways, negative 6 minus 1 is negative 7 plus 4 is negative 3. And that's going to equal negative W. So I never solve for a negative W. I always solve for a positive W. So I'll divide everything by negative 1. So I'll get negative 2V plus 3 is equal to W. So there we go. Just some solving practice of some equations. Hopefully that makes sense. If there's any that confuse you, feel free to ask questions about it. Have a good day.